Hello class, this is Sir Ash and this is our review on pharmaceutical calculations.
Here's the outline for this presentation. So today, hopefully, you will learn about the different concepts and techniques that are applicable in pharmaceutical calculations. So let us note that in this subject, practice is key.
Let's start with the fundamentals. Pharmaceutical calculations is the area of study that applies the basic principles of mathematics to the preparation and safe and effective use of pharmaceuticals. First, let us recall the concepts of fraction, percent, ratio, and proportion. Let's start with fractions. I'm sure that you know what a fraction looks like. Fractions are portions of a whole expressed with a numerator and a denominator. So the numerator is the number found above the bar line, while the denominator is the number found below the bar line. In adding and subtracting fractions, we must note that the fractions should be similar, meaning they should have the same denominators. In cases where the denominators are not the same, we should first find the least common denominator. This is the number in which the numbers are divisible from. For example, we have 1/4 and 2/5. 4 and 5 are the denominators, so the least common denominator is 20. So when you divide 20 by 4, you get 5. When you divide 20 by 5, you get 4. So in order to find the numerators for the new fractions, we should first divide the least common denominator with the denominator of the first addend. So we have 20 divided by 4, we have 5, and multiply it with the numerator, that is 1. So 20 divided by 4 is 5, times 1 is equal to 5. So that means that 1/4 is equal to 5 over 20. Next, 20 divided by 5 is equal to 4, and 4 times 2 is equal to 8. So we will have 8 over 20. Since they now both have the same denominators, we can simply add the numerators. 5 plus 8 is 13, so we will now have 13 over 20. So you should try the second example.
In multiplying fractions, we simply multiply the numerators and the denominators. So in this example, if the adult dose of a medication is 2 teaspoonful, calculate the dose for a child if it is 1/4 of the adult dose. So 1 over 4 times 2, since 2 is a whole number, it will always have a denominator of 1. So 1/4 times 2 over 1 is equal to 2/4, and 2/4 can be simplified to 1/2. In division, you would do, it is similar with multiplication, but you will first find the reciprocal of the second number. When I say reciprocal, you exchange the places of the numerator and the denominator. So an example, if a child's dose of a cough syrup is 3/4 teaspoonful and represents 1/4 of the adult dose, calculate the corresponding adult dose. So in this, we have 3/4 teaspoon divided by 1/4. So instead of simply dividing the numerators and the denominators, we would first find the reciprocal of the second fraction, that is 1/4. So we exchange the places of 4 and 1. So we will now have 4 over 1. So after that, we will proceed with multiplication. So 3 over 4 times 4 over 1 is equal to 12 over 4. And 12 over 4 can be simplified to 3. So the answer is 3 teaspoons.
Since you know about fractions, I'm sure you also know about decimals. So decimal fractions are fractions with a denominator of 10 or any power of 10, can be 100 or 1000, and they are usually expressed decimally rather than as a common fraction.
So to convert a common fraction to a decimal fraction, you simply divide the denominator into the numerator. For example, 1 over 8 can be converted to decimals by simply dividing 1 to 8. So 1 divided by 8 is equal to 0.125. And to convert this back to a common fraction, you can express this decimal fraction as a ratio and reduce. So for example, 0.25 is also equal to 25 over 100. And since this can be simplified, we will have 1 over 4 or 1/4. So when common fractions appear in calculations, it is often best to convert them to decimal fractions before solving. The reason for this is that decimals are more straight to the point than fractions. So you may commit more errors when dealing with fractions rather than with decimals. Next is percent. Percent means parts per hundred. So common fractions may be converted to percent by dividing the numerator by the denominator, which we have done a while ago. So it just means simply converting fractions to decimal fractions and multiplying them by 100. For example, 1 over 5 is equal to 0.20. And to get the percentage, you should multiply this by 100. So 0.20 times 100 is 20%. Now, decimal fractions may be converted to percent by simply multiplying by 100. So I'm quite sure that you have been familiar with the relationships between the common fraction, the decimal fraction, and the percent. So this table shows equivalencies of certain values. So let's have an example. Let's have 1 over 10. So 1 over 10 is a common fraction. If you convert it to decimal fraction, you simply divide 1 by 10 and you get 0.1. And if you want to further convert it to percent, you only need to multiply it by 100. So 0.1 times 100 is equal to 10%. So you can do this for any fraction, or decimal fraction, or percent. For sure, in calculations, we sometimes arrive with very large or very small numbers. Now, a method of writing these is the exponential notation. Now, we also have to take note of certain points when dealing with operations involving exponential notation. In multiplication, we simply add the exponents, and in division, we subtract the exponents. So example, we have 2.5 times 10 to the second power times 2.5 times 10 to the fourth power. You should first multiply 2.5 and 2.5. You'll have 6.25. And then you add the exponents, which is 2 and 4. So that would be 6.25 times 10 raised to the sixth power. And this can be rounded up to 6.3 times 10 to the sixth power. In division, we have this example, 7.5 times 10 to the fifth power divided by 2.5 times 10 to the third power. You divide 7.5 by 2.5, that is 3, and you subtract 5 and 3. And then you'll have 3 times 10 to the second power. So you can look at the other examples so that you'll have practice in solving problems involving exponential notation. In adding and subtracting exponential notation, expressions must have the same exponents. So let's look at the example. 1.4 times 10 to the fourth power plus 5.1 times 10 to the third power. So they don't have the same exponents, right? So the first thing you need to do is to convert one of them so that it will have the same exponent as the other. So we had 1.4 times 10 to the fourth power, and we converted 5.1 times 10 to the third power into 0.51 times 10 to the fourth power. So it means that they are equivalent. So since now they have the same exponents, we can simply perform the operation. So 1.4 plus 0.51 is 1.91 times 10 to the fourth power, or simply 1.9 times 10 to the fourth power. So let's have another example. We have 1.4 times 10 to the fourth power minus 5.1 times 10 to the third power. So we have the same given, but we will apply a different operation. So first, what we did was we converted 1.4 times 10 to the fourth power into 14 times 10 to the third power. And then we proceeded with the operation. So the answer is 8.9 times 10 to the third power. Okay, guys. So we should take note that when we move the decimal to the left, the exponent increases, as seen here. From 5.1 times 10 to the third power, we move the decimal to the left of 5. It became 0.51. So the exponent increased by 1. While in this example, 1.4 times 10 to the fourth power, we moved the decimal to the right. So we had 1.4 times 10 to the fourth power converted to 14 times 10 to the third power. From 4, it became 3. Okay, so practice on your exponential notations so that you will not be confused, okay? So practice with this example. Next is ratio and proportion. So ratio and proportion are often put side by side because they are related. So ratio is the relative magnitude of two quantities, while proportion is the expression of the equality of two ratios. So here, 1, 2, 3, these are expressions for proportion. So we have A is to B is equal to C is to D. So this is one ratio and this is another ratio, and this expresses the equality of the two ratios. So 1, 2, 3 are all similar. They are the same. So going here, if A over B is equal to C over D, then you'll have these. So it is a required skill that you know how to derive formulas. So because if you do, everything would be so much easier. So how did we arrive at this formula? Ganito. So first, let's find A. Okay. So we simply cross multiplied B with C. So that became A is equal to B times C over D. You're left with A, right? So that's it. Next, let's find B. B is in the denominator. So how do you find B? So if you cross multiply A with D, you won't get B is equal to C over A times D. What you need to do is to cross multiply A to D and B to C. So you will have A times D is equal to B times C. So since B is not yet alone, meaning it still has C by its side, you should divide both sides by C. So that's what we did here. So since you divided C here, it got cancelled since they are the same. I mean, it contains the same variable. So we now have B is equal to A times D over C. So C and D can be derived the same way. Okay. So it is important to label the units in each position to ensure proper relationship between the ratios of a proportion. So you need to practice in deriving formulas, okay? To practice and try to understand how we got this. Okay, so here are examples. So I placed the formulas here for guidance. Okay, so first example. If 3 tablets contain 975 milligrams of aspirin, how many milligrams should be contained in 12 tablets? So the approach in solving these kinds of questions is to first understand the problem or what is asked. So we are asking how many milligrams should be contained in 12 tablets. So we are looking for an amount. Okay. So next step is you write the given. So we have 3 tablets and we should note that it contains 975 milligrams of aspirin. And what is being asked is the quantity or the number of milligrams that is contained in 12 tablets. Okay. So after that, we should write this in a formula. So what formula can be used? You can choose any of these, but it was written this way. So we have 3 tablets and it contains 975 milligrams. Okay. Now we are looking for the number of milligrams that can be found in 12 tablets. So we place 3 tablets and 12 tablets on one side and 975 milligrams over x on the other side. So x is what you want to find. So how do we find x? So in this formula, that is D. So D is equal to B times C over A. So it became, this is B, this is C. So it became 12 times 975 divided by 3. And the answer is 3,900 milligrams. Okay. So let that sink in. So another example. If 3 tablets containing 175 milligrams of aspirin, how many tablets should contain 3,900 milligrams? So in this problem, what is asked is the number of tablets that should contain 3,900 milligrams. So you write the given, you have 3 tablets again, and it contains 975 milligrams. And then you use X for as a variable for the tablets, and you have 3,100 milligrams. So we will do what we did a while ago. So we simply look for X. So X can be derived by this formula. X is equal to 3 times 3,100 divided by 975. So 12 tablets is the answer. So I suggest that you pause this slide and you try to practice and understand how we arrived with the answers. So practice is key. Okay?
One of the foundations of pharmaceutical calculation is dimensional analysis. So it is also known as factor analysis, factor label method, or unit factor method. So it involves the logical sequencing and placement of a series of ratios into an equation. So some terms are inverted to their reciprocals. So I've told you about finding the reciprocals. So you just exchange the numerator and the denominator. So this is done to permit the cancellation of like units in the numerators and denominators and leave only the desired terms of the answer. So in computation, units are very important. So let us be wary of the units that we use, okay? So the steps in dimensional analysis involve, number one, identifying the given quantity and its unit of measurement. You do not simply write the number, you should also include the unit. So, for example, if someone asks you how much you weigh, you do not simply say, I weigh 60, because 60 would be meaningless. It should have a unit, so you will say, I am 60 kilograms, or I am 120 pounds, okay? So units are very important. Next, you should identify the wanted unit of the answer. So in the questions, you should find or you should know what unit is being asked, because sometimes questions can be tricky, okay? So there will be times that the given will be, for example, in grams, but the unit required is or should be in milligrams, okay? So you should always take note of the wanted unit. Next, step 3, you should establish the unit path and identify the conversion factors needed. So this might include letter A, a conversion factor for the given quantity and unit, and or a conversion factor to arrive at the wanted unit of the answer. So there's a list of conversion factors that will help us or that will help us make our lives goes easier. Okay, so in computing, so we only need to memorize them. For example, uh, we should convert inch to centimeters. So 1 inch is equivalent to 2.54 centimeters, or converting 1 kilogram to pound, 1 pound is equal to 2.2 pounds. Parang ganun. So we should memorize. Okay, after that, after identifying or establishing the conversion factors, you should set up the ratios in the unit path such that cancellation of units of measurement in the numerators and denominators will retain only the desired unit of the answer. So what does that mean? When you place units in the numerator and the denominator, you can cancel them if they are the same. For example, um, 5 pounds divided by 1 pound. So 5 divided by 1 is 5, but what unit will be left? There will be none, because both the numerator and the denominator have pounds as their unit. Okay, but for example, if the given are 40 meters and 20 seconds, so you will have 40 meters over 20 seconds. That would be 2. Okay, 40 divided by 20 is 2. Can you cancel the meters and the seconds? No, you cannot, because they are not the same. Okay, so the answer would be 2 meters per second. Okay, so there will be lots of examples as we go on with this presentation. And lastly, um, you perform the computation by multiplying the numerators, multiplying the denominators, and dividing the product of the numerators by the product of the denominator. So just like what we did with the examples a while ago. Okay, so I hope you understand or you grasp this concept, because this will be really helpful as we go on with the subject. Okay, so here is an example. How many fluid ounces are there in 2.5 liters? So the first step is to identify the given. So we have 2.5 liters. Again, the unit is important. 2.5 liters. Next, we identify the required unit. So the required unit is fluid ounces. So we convert 2.5 liters to fluid ounces. Next, we identify the conversion factors that can be used. So we have 1 liter is equal to 1000 ml, and 1 fluid ounce is equal to 29.57 ml. So why are these the factors to be used? Because they are related, or
they have like terms that can be cancelled. So after identifying those, we set up the unit path. So we have the given quantity, which is 2.5 liters. And we have the conversion factors of 1 liter is equal to 1000 ml, and 1 fluid ounce is equal to 29.57 ml. So let's take a look at this part here. So as you can see, the conversion factor for ml to liter has been reciprocated. So instead of the liters unit being the numerator, the ml is in place. So why is that? Because that is the only way that we can cancel out the liters unit. Okay? Because again, when you have the same unit in the numerator and the denominator, you can cancel out those units. So what is left would be the ml unit. Okay? So if we do the problem over here, 2.5 liters times 1000 ml is equal to 2500 ml times liter over 1 liter. And since there are like units, we can cancel the liters, and we only have 2500 ml. Next, we do what we did with ml to liters with fluid ounces and ml. So we have 1 fluid ounce over 29.57 ml, and our answer would be, okay. Before that, let us note that the unit path is set up such that all units of measurement will cancel out except for the unit wanted in the answer. So fluid ounces, which is placed in the numerator. So, well, that's a good thing to note, that whatever unit you require, it should be placed in the numerator. Okay. So, ayun. So let's compute. So this is the flow of the computation. There. So 2.5 liters times 1000 ml over 1 liter. So first, the liters unit will be cancelled. Okay, so dapat cancel din to. Then times 1 fluid ounce over 29.57 ml. So since ml over ml, they will also both be cancelled. So what we will be left with, fluid ounces, and the answer is 84.55 fluid ounces. So there's a note that the student may wish to see the problem solved by ratio and proportion. So this means that there is no single solution to every problem. So you can have different approaches, and you will ultimately arrive at the same answer. So you can have this 1 liter over 2.5 liters is equal to 1000 ml over x. Okay, so the answer is 2500 ml, and then use this, and the answer is the same, 84.55 fluid ounces. Okay, so let's have another problem. So a 15-month-old child who weighs 25 pounds is running a fever, and her mother decides to give her acetaminophen. A bottle of acetaminophen suspension with a strength of 80 milligrams per half teaspoonful is available at home. If the standard dose for acetaminophen is 10 milligrams per kilogram, how many ml should be given to the child? So let us first identify what is asked. So we want to know how many ml of medicine should be given to the child who weighs 25 pounds, assuming that the standard dose for acetaminophen is 10 milligrams per kilogram, and that the available strength of acetaminophen is 80 milligrams per half teaspoonful. Okay, so there are lots of units involved, but if you get to identify the required conversion factors, and you're able to appropriately set them up in a unit path, the answer will come easy. So what they did is first write the given 25 pounds, and next they converted the pounds into kilograms so that you can work with the given standard dose, that is 10 milligrams per kilogram. And after identifying the number of milligrams that is needed, we use the available strength of 80 milligrams per half teaspoonful. So when we say half teaspoonful, that is 0.5 teaspoons. And since the required unit is ml, we should convert it to ml. Okay, so there is a long way to go, but we will arrive at 3.6 ml. Okay, so take note that the units are cancelled except for ml. Why? Because the units can be found at the numerator and the denominator. So since this is the case, they can be cancelled. Okay, so LB, LB, kg, kg, mg, mg, teaspoon, teaspoon. So since ml has no other partner in the denominator, it cannot be cancelled, and therefore it is the final unit. Okay. Next, let us have the International System of Units.
Weights and measures. So how do we differentiate the two? So weight is the measure of the gravitational force acting on a body. It is directly proportional to the body's mass. So the greater the mass, the greater the weight. Measure, on the other hand, is the determination of the volume or extent of a body. It is affected by temperature and pressure, especially in liquids and gases. There are three known measurement systems. First is the metric system. Second is the English or imperial system, further subdivided into the apothecary system and the avoirdupois system. And third is the common or household system.
Let's start with the metric system. So the metric system, or now called International System of Units, was introduced by France in 1799 by the International Bureau of Weights and Measures. So it makes use of the convenience of the number 10. So here are the known units. Okay, we have for length we have meter, for quantity, for mass we have kilogram, for time we have second, electric current we have ampere, for temperature we have Kelvin, for the amount of substance we have mole, and for luminous intensity we have candela. So memorize these. So for the quantity mass, the desired unit is gram or kilogram. So we should know that 1000 grams is equal to 1 kilogram. So let us note that 1 gram is the weight of 1 cc or cubic centimeter of distilled water at 4 degrees Celsius. And the standard mass of a platinum iridium cylinder preserved in a vault in France is the basis for 1 kilogram. Next, for length, we have meter. The basis for this during the old times is 1 over 40 millionth of the Earth's polar circumference. But today, it is defined as the distance light travels in a vacuum in 1 over 299,792,438 of a second. So this is the speed of light. And for the volume, which is, it has the unit of liter. So let's note that 1 liter is equal to 1 cubic decimeter, and it is also equal to 1000 cubic centimeters. So 1 liter of pure water weighs almost exactly 1 kilogram. So that means 1 cubic centimeter of water is equivalent to 1 ml and weighs 1 gram. Next. So here are metric prefixes. So we have heard a while ago about the kilo and the milli. So let us memorize these prefixes. Okay, so the basis is this. We have 1. So if you want a kilo, it will be multiplied 1,000-fold. Okay, so this. And if we have micro, it will divide it by a millionth. So memorize, 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 memorize. So now let's have the apothecary system. The apothecary is the pharmacist or the dispensing chemist during old times. So this method is used for compounding medicine. So when I say compounding, it is preparing in small scale. Although this is a now obsolete system, it is still commonly used for ordering the following. So these are nitroglycerin, atropine, codeine, and morphine. So this system includes or involves the following units. We have pound, ounce, dram, scruple, and grain. So how do you use this table? So we have 1 pound equivalent to 12 ounces. 1 pound equivalent to 12 ounces. 1 pound equivalent to 96 grams. 1 pound equivalent to 288 scruples and 5,760 grains. Okay. While the 1 ounce is equivalent to 8 grams, 24 scruples, and 480 grains. 1 gram, 3 scruples, 60 grains. 1 scruple is equal to 60 grains. Okay, so you need to memorize this. Okay, so you can find yourself some techniques. So whatever works for you would be the best. Okay, aside from that, for fluids, we have these units. We have gallon, quart, pint, fluid ounce, fluid gram, and minims. So the same goes. So 1 gallon is equal to 4 quarts. 1 quart is equal to 1 pint. 1 pint to 16 fluid ounces. 1 fluid ounce to 8 fluid grams. And 1 fluid gram equals to 60 minims. So here is a mnemonic you can use. We have GQ papas equals fluid ounce of drama, so minimize. Okay, so 4 to 16, 860. Again, GQ papas equal fluid ounce of drama, so minimize. 4 to 16, 860. So what does that mean? 1 gallon is equal to 4 quarts. 1 quart is equal to 2 pints. 1 pint is equal to 16 fluid ounce. 1 fluid ounce is equal to 8 drams. And 1 dram is equal to 16 minims. Okay, so again, GQ papas equals fluid ounce of drama, so minimize. 4 to 16, 860. Next is the avoirdupois system. So avoirdupois means heavy goods, goods of weight, or to have weight. So it is a standard for weights in commerce. So fluid measures are the same as apothecary measures. So here we have 1 pound is equal to 16 ounces, and 1 ounce is equal to 437.5 grains. Again, memorize. For the household system, we have the following. 1 teaspoonful is equal to 5 ml. 1 liter spoonful is equal to 8 ml. 1 tablespoonful is 15 ml. Wine glassful 60 ml. Teacupful 120 ml. And tumblerful 240 ml. But the more common or most common factors are 1 teaspoonful, 5 ml, 1 tablespoonful, 15 ml. Exercise. So here is an exercise for you. So you answer this on your own, okay? And here are the answers.